In sex determination part 1, we have already discussed the heterogametic males, heterogametic females, and haplodiploidy type of sex determination. Now, myself, Dr. Mangal Patwardhan, Head Department of Botany, Gupte Jogrekar College, Ratnagiri, is going to describe the sex determination part 2. We are going to discuss the genic balance theory of sex determination with respect to fruit fly, that is Drosophila. Fruit fly possesses 3 pairs of autosomes and 1 pair of sex chromosomes in diploid cell. The sex chromosomes are XX and XY. The total number of chromosomes in haploid condition are 4, 3 pairs of autosomes and 1 pair of sex chromosome XX and XY, but the mode of sex determination do not show XX XY pattern. The sex chromosomes of Drosophila are X and Y. The X chromosome is long and rod-like, while Y chromosome is hooked. Every individual fruit fly carries the genes for maleness and femaleness, and the proportion of autosomes to X chromosome in an individual determines its sex. Kelvin Bridges showed that the female determiner is located on the X chromosome with strength of 1.5 and the male determiner on autosomes with a strength of 1 for the autosomal genome. A fruit fly with chromosome complement AAXX, where A is one haploid set of autosomes with a female determining value of 1, has the ratio of male is to female determiners as 2:3. Since 3 is more than 2, the fruit fly will be a female. A fly with XXXY chromosome combination will have male is to female determiners as 2:1.5. Since 2 is greater than 1.5, the fly will be male. Considerable support is given by the studies of fruit fly, and after that the abnormal distribution of the chromosome in Drosophila came into existence. So now we are going to see the sex expression in Drosophila considering the male and female determiners. This table shows 3 columns. In column 1, chromosome combination is noted. In column 2, male is to female determiners proportion is noted, and in third column, sex expressions are mentioned. So now we'll see one by one the details of chromosomal combinations. The first combination is AAXX. Autosome is of strength 1 and X chromosome is of strength 1.5. So its male is to female determiner ratio is 2:3, and hence the sex expression will be female. Second, AAXY. AA, that is 2, and X is having 1.5 value, Y has no determiner value. So 2 is to 1.5 gives rise to male sex expression. Third one, AAAXX. So male is to female determiner ratio is 3 is to 3. Hence, it is expressed as intersex. Fourth combination, AAX. 2 is to 1.5. Here, Y chromosome is absent. Hence, it will produce the male by ratio, but the male will be sterile. Next combination is AAXXX. Male is to female determiner ratio 2 is to 4.5. Hence, the sex expression will be super female or meta female. But the females will be low in viability. Next combination AAAXY 3 is to 1.5 ratio. Expression will be super male or meta male. Next combination AAAA XXXX 4 is to 6, as here 4 sets of autosomes and 4 sets of X chromosome are there. The sex expression will be tetraploid female. Next combination AAXXY 2 is to 3, expression is female. Next one AAAXXX. Here 3 sets of autosomes and 3 sets of X chromosomes are there. So it will develop the triploid female. Now we'll consider the sex expression in Drosophila based on X is to A ratio. Alternatively, we can determine the sex of a fly by finding out X is to A ratio, that is number of X chromosome is to number of autosome sets, and hence we'll observe the table written here with 5 columns. First column shows the chromosome combination. In second column we have mentioned number of X chromosomes. In third column number of sets of autosomes. In fourth column the proportion of X is to autosomes, and finally it is the sex expression mentioned. So in chromosome combination 1 is AAXX. So number of X chromosomes are 2, number of autosomes 2, X is to A proportion 2 is to 2, that is 1, and it expresses female characters. AAXY, number of X chromosome 1, number of sets of autosomes 2, X is to A proportion 1 by 2, that is 0.5, represents the AAAXX, 2 X chromosomes, 3 sets of autosomes, 2 is to 3, that is 0.66. It is showing the intersex. AAAXY, X chromosome 1, sets of autosomes 3, 1 is to 3, that is 0.33, super males. AAAXXXX, 4 X chromosomes, 3 sets of autosomes, and X is to A proportion 4 is to 3, that is 1.33, super female. Last combination AAAXXY, 2 X chromosomes, 2 sets of autosomes, 2 is to 2, produces 1 and expresses as female. So with this background, if we know the number of X chromosomes and the number of sets of autosomes which sex expression will be produced in the offsprings that we can easily determine. In rare cases, the X chromosome of Drosophila fails to separate during meiosis I of oogenesis, and both X chromosomes go to one pole of meiotic spindle. This gives some eggs with the normal single autosomal genome but with two X chromosomes, and some eggs with normal single autosomal genome but with no sex chromosome at all. Such an unusual occurrence is called the non-disjunction of X chromosome. The result of fertilization will produce normal females, normal males in appearance, but sterile, and super females which will be sterile and somewhat underdeveloped in her sexual characters. The offsprings which receive only the Y chromosome and no X chromosome will die naturally. The abnormal meiosis may also result in non-disjunction of the autosomes and the sex chromosomes forming diploid gametes. Those offsprings with three sets of autosomes and three X chromosomes will have the same sex ratio as found in normal females and therefore will be females with a triploid chromosome number. A fly that receives three autosomal genomes and two X chromosomes have the sex ratio 3:3, and the fly will be intersex with sexual characteristics intermediate between the two sexes. It will be possible to produce a super male like a super female. From the data, Bridges concluded that the Y chromosomes in Drosophila lacks the male determining factors but apparently contains genetic information essential to male fertility because the X0 males were sterile. Now we will consider the next part, that is gynanders or gynandromorphs. The Greek word gyne, that is woman, aner, that is man, and morph, that is form. Organisms in which the body consists of both male and female parts and show female and male characters are sex mosaic. These animals has one part of the body female and other part showing male features. Gynanders may be bilateral or anterior-posterior. For example, silkworms, bees, fruit flies, etc. Zygote with AAXX configuration during meiosis. At first cleavage of the zygote, an X chromosome may lag behind and not arrive in time to be included in the nucleus. In such condition, the daughter cells have AAXX and AAX0 configuration and it becomes intersex with half part male and one half part female. So now we'll consider the gynandromorph in Drosophila. It was first described in Drosophila by Morgan and Bridges. Gynander or gynandromorph are sex mosaics showing one part of the body with male characters and other with female. For example, considering a zygote with a chromosome configuration AAXX during meiosis at the first cleavage, depending on the position of sex tissues, a gynander may be bilateral or anterior-posterior. Thus, in this photograph, we can observe the 50% part of this fly is showing male characters and 50% part is showing female characters. Thus, gynandromorph in Drosophila shows bilateral symmetry in the body features. So, Drosophila is showing variations in sex determination. So, in this part, we have seen the genic balance theory of sex determination and the production of gynandromorphs. Thank you.